Before plumbing existed, before cities, copper pipes, or even written language, humans were already solving one of civilization's biggest problems: how to move and store water. In this video, we'll uncover one of the world's most mysterious ancient sites, Karahantepe, an 11,000-year-old settlement in southeastern Turkey, and explore whether the people who built it had their own primitive but genius water system. Because the story of Karahantepe challenges what we know about early human intelligence and technology. So how did they do it? Without metal, without machines, and without plumbing? Let's find out. Karahantepe, sometimes spelled Karahantepe, is located near the city of Şanlıurfa, Turkey. It's part of a group of prehistoric mound sites known as the Taş Tepeler, stone hills, which also includes the famous Gobekli Tepe, the world's oldest known temple complex. Archaeologists date Karahantepe to the pre-pottery Neolithic period, around 9,500 to 9,000 BCE, meaning it was built over 11,000 years ago, long before agriculture or pottery became common. Excavations have revealed dozens of T-shaped stone pillars carved with animal motifs, intricate underground chambers and circular rooms, a massive central hall carved directly into bedrock. These discoveries prove that early humans at Karahantepe had advanced architectural and organizational skills, far more complex than we ever imagined. But this leads us to a fascinating question. If they could carve entire halls and pillars from stone, could they also engineer ways to move water? To understand what may have existed in Karahantepe, we first need to look at how ancient civilizations across the world handled water, long before plumbing as we know it. Here are some of the oldest and smartest examples. 1. The qanats system, Persia and Iran. These were underground tunnels that carried water from mountain aquifers to distant villages, purely using gravity. Vertical shafts were dug at intervals for ventilation and maintenance. This system dates back over 3,000 years and is still in use today. 2. Cisterns and rainwater storage, Mediterranean and Middle East. Ancient cities built underground tanks to collect rainwater and runoff. These cisterns were lined with plaster or stone to prevent seepage. Many early temples and homes had their own water storage pits. 3. Roman aqueducts and lead pipes, Europe. The Romans perfected long-distance water transport. Using stone arches and gravity-fed channels, they moved fresh spring water across miles, supplying cities, fountains, and baths. 4. Indus Valley and Sri Lankan tank systems. The Indus civilization, in modern Pakistan, India, built brick-lined drains and reservoirs. Sri Lanka's tank cascade system used a chain of reservoirs to reuse water for agriculture, an early form of eco-engineering. These examples show that ancient water systems all relied on 5 basic principles: gravity flow, no pumps; underground channels to prevent evaporation; branching networks for distribution; storage tanks for drought periods; access shafts for cleaning and repair. Now, let's imagine, if people in Karahantepe were this organized, could they have applied the same ideas, even in simpler form? While there's no confirmed evidence of a complete water system yet, archaeology allows us to hypothesize how one might have worked. Here's a plausible reconstruction. 1. Collecting water. The Karahantepe region has seasonal rainfall and nearby valleys. Rainwater could have been collected from stone-carved surfaces and directed into basins or small reservoirs. 2. Stone channels or underground passages. Shallow grooves carved in stone might have guided water toward specific areas, similar to small qanat-style channels. If underground tunnels existed, they would have reduced evaporation and kept water cool. 3. Maintenance shafts. Vertical openings could provide access for cleaning or ventilation, just like in Persian qanats, an early form of engineering foresight. 4. Central storage tanks, cisterns. Water might have been stored in large stone-carved chambers, acting as communal water reserves or ritual purification pools. 5. Distribution to key areas. From these central basins, small trenches could lead water to ritual spaces, living areas, or agricultural plots nearby. 6. Wastewater drainage. An efficient community would also need to drain excess or dirty water, perhaps through carved stone gutters leading away from the site. So far, excavations at Karahantepe haven't revealed any explicit water tunnels or pipes, but the site's architecture shows remarkable planning and precision. Experts describe it as a masterpiece of prehistoric engineering. Its symmetrical rooms, drainage-like depressions, and carved floors hint that the builders understood water flow and control. Some archaeologists speculate that ritual water use might have been part of its design, perhaps for cleansing ceremonies or symbolizing life and rebirth. However, since the site is still under excavation, these ideas remain theoretical, but highly intriguing. The absence of physical pipes doesn't mean they didn't have a system. It could have been open channels, wooden troughs, or clay-lined paths that simply haven't survived over millennia. To better understand what Karahantepe's system might have been like, let's compare it to other ancient technologies. Like the Persian qanats, it could have used underground gravity-fed flow. Like Roman aqueducts, it could have included stone channels or trenches. Like Indus Valley cities, it might have had a dual system, one for clean water and one for waste. Like Mayan reservoirs, it may have used natural depressions in the bedrock to collect rainwater. These examples show that hydraulic ingenuity existed long before metal, and Karahantepe's builders might have shared this global understanding. Let's break down the science behind how such a system could function. 1. Gravity and slope. All ancient systems relied on natural slopes, letting gravity do the work of moving water downhill. 2. Flow rate and channel size. The width and depth of a carved trench would determine how fast water could flow. A balance was crucial. Too fast, and erosion occurs. Too slow, and stagnation happens. 3. Evaporation control. Shallow covered channels or underground passages protected water from sun exposure and loss. 4. Sediment management filters, or sediment pits, prevented mud from clogging the flow, an early form of water purification. 5. Maintenance shafts. Vertical shafts allowed ancient engineers to inspect, clean, and ventilate their systems, essential for sustainability. If Karahantepe followed even a few of these principles, it would show that prehistoric people understood natural hydraulics centuries before modern science. Let's sum it all up. Karahantepe remains one of the world's most mysterious ancient sites. Although no direct proof of a plumbing-like system exists yet, its design, complexity, and architecture suggest that early humans there were capable of advanced planning and engineering. By studying ancient systems like the qanats of Persia, Roman aqueducts, and Indus Valley drains, we can imagine how such knowledge might have emerged independently in multiple parts of the world. The lesson is clear. Even before modern tools, human creativity was limitless. People used nature's forces, gravity, rock, and rain, to survive and thrive. Maybe the true genius of Karahantepe isn't just in its stones, but in the minds of those early humans who looked at the barren earth and thought, "We can make water flow."